Hey everyone, today we'll be going over binary search trees today. Particularly we will be focusing on removing a node inside of a full binary search tree, and without any further hesitation, let's get started. And now we're going to be focusing on removing a node inside of our binary search tree. So really what we need to do, I also need to create a another function to consider finding the smallest node. This is going to be very important when we start building it out. The first thing we need to do is have node remove rec node int data. Go over here. We are going to check if the node is null, just return null. So if not null, we just return null pointer. Then we need to find where to remove the node, and we must consider when a node has two children. So first, when we're finding the node, we look on the leftmost side and the rightmost side, and we'll just ignore this error for now. So we'll have if data is less than a node with the respective data, we will have the node at the left-hand side equal to remove rec. We're just going to call upon that function to get the data from the left-hand side of the binary search tree over here, and then we'll have else if the data is greater than the node specifically for the data over here, and then we'll just check to see for the right is equal to remove rec. It's similar to what we did before up here. Actually, I made a bit of an error, so it should be left over here, and this should be right with the respective data. And then we'll have else over here. We will check if the node only has one child or no child. So if the node is not at the left, if there's nothing available at the left, then we're going to have temporary, and we're going to switch by doing node temp equal to node to the right. We're going to delete the following node that we have, and then we're going to return the temp. And so else if node, if there's nothing at the right, then we're going to do the same thing, except for we're just going to focus on having a temporary node on the left. So left over here, and then we'll delete the node and replace it with the temp. That's what we do. And then we'll consider the node with two children in this case. So that means we're going to do the same swap technique that we did before. So we're going to have node temp equal, this is where the other function also comes in as well, min value node, where we're going to call this upon the node with the right, node with the respective data, temp data, node right, move rec. We're considering on the right first, and then instead of our min value node function that we're going to build out later, we're going to put the data of the left-hand side, as we consider from the leftmost to the rightmost, because left is less, right is more. Return node. There we go. Should be no errors right up here. Okay. That's because we did not, and the reason why we're getting this error is because we did not declare it, but this is what we do. We're going to call node, min value node, and put a parameter of node be here. And so we're going to find the left most leaf by doing so with node current equal node, and while the current and the current left doesn't equal null pointer, we're just going to have to redeclare current equal to the current on its left, similar to the pattern what we did above over here. Then finally, we're just going to return current inside. There we go. So let me just build this, make sure it's all good. Building, and it works. So now let's head over to our main function to know exactly what to do. But first, since we have a second public instance for the function we will call upon, that means what I'm going to do is that we will remove a node from a tree, from a binary search tree. That means void remove int data for at its respective root that we have called will be equal to remove rec with the root and respective data as well. So it's calling upon this function that we made above over here. There we go. I also have the links in the description as well. Let me build this, make sure. Build succeeded, and now what we will do is that we will now head over to our main function and then focus on removing the tree, the node inside of a tree as well. So we will remove 20. So all I gotta do is just tree.remove. Look, notice how we did remove, and we call upon this function here. Let's call upon that function. So we have the data. So I'm gonna remove 20. Then I'm gonna print out the tree again to show you exactly what it will look like. Here we go. We don't have to declare this again. This should be good. I can move this up here actually just to keep everything clean and organized. There we go. We're gonna put make sure you have your semicolons over here. So task 1, let's insert. Task 2, remove. We're gonna remove 20, and then we're gonna output. So let me build this, make sure it's good. Let's run this, and voila, we have removed 20. And look, we put 25 up here. This reflects the nature of our binary search tree over exactly removing a specific node from our full binary search tree overall. So yes, this was the task to remove a binary search tree. Now that we have done so, let's move over to our next task and focus on performing in-order traversal for our full binary search tree. Hey everyone, thank you very much for taking time to watch this. If you found this video helpful, be sure and feel free to please like and subscribe. And if you do have any other questions or suggestions, please put them in the comment section. And as always, take care. Cheers. Bye-bye.